day 2. We're going to start with our real world math problems. We've got a dirt bike and it is jumping off of a ramp, and we're just looking for the height after 1.75 seconds. So let's set up our graph. On the y-axis, we have height in feet, and on the x-axis, we have time in seconds. Now let's decide what kind of units we're going to have. We have 0, 0.5, 1, 1.5, and 2. And I can see that's probably all going to fit right here. So I'll put 0.5, 1, 1.5, 2, 2.5, and 3. On the other axis, we go up to 24. So if I think I number by 4, I could do 4, 8, 12, 16, 20. I'm right, that's 24. Plot your points. This is just like we did on the do first for the first day. Go to 0, 8, 0.5, 20, 1, 24, 1.5, 20, and the very last one you're going to do is going to be 2, 8. Once you get your points on there, you can start to see the way the dirt bike's going to move when it comes off the ramp. It's going to come up, it's going to hit a peak, and then it will come right back down. And I'm going to leave it right here, only because I don't have more data. I think in the real world, you probably, if you had an 8-foot tall ramp, you'd probably then land on the ground, somewhere over here. But since I don't have the data, I'm going to leave it just like that. It does ask me to estimate the height after 1.75 seconds, so I'm going to dot that in. Here's 1.75. I'm going to hit my axis here, and it looks like it's about 16. So what I can say is that this is a quadratic function, and I can say that the height of the function at 1.75 seconds is going to be about 16 feet, like that. Now this is my final answer, so I want to go ahead and box it in. Alright, so let's move on to the next one. It's going to talk about a chainsaw, and over time it's going to be emptying out the gas tank, and we just want to figure out how long that's going to take. So we're going to do the same thing. The y-axis is fuel remaining, and that's in ounces. And then our x-axis is time in minutes. So 0, 10, 20, 30, 40. I can probably do 10, 20, 30, 40. Fine. And I'll number it all the way. I'll number my axis all the way out. And then on the other side, we can go up by, 15 is the highest and 3 is the smallest. So 3, 6, 9, 12, 15, and 18. Let's go ahead and graph this in. We've got 15, 0, 15, 10, 12, 20, 9, 30, 6, and 40, 3. Again, you know that the gas tank will get empty at some point, and so we're not going to actually go all the way because our data stops. But in the real world, we know we have that part. This is going to be a linear function, and it's asking us how is the function transformed from the parent function. You can see that your normal parent function is just going to be your straight line like that. So this has obviously been a reflection. We know that for sure. The slope on this is negative, and our parent function is y equals, that's a positive slope. Reflection is the first thing. My slope here, I go down 3 and over 10. 3 over 10 is less than 1, so I also know that this is getting flatter. And my parent function always starts at 0, but this one starts at 15. So I know that this also been shifted up 15 units. So here are my 3 translations. Here's my parent function, and it's asking us when the tank will be empty. Well, there's not going to be any fuel left, so at all when x is what? When x is 50. So the function at 50 has to equal 0, which is totally true. That happens right here. The final answer here is at 50 minutes. The tank is empty. And there you go. The only other one that you need to do is your battery life of your computer. So we're going to plot this out. Battery life is on Y, and I'm actually going to put battery, and then I'm going to put my percent sign here because we measure all of these in percent. The time in hours goes on my x-axis. I'm going to label 2, 4, 6, 8, 10, and 12 on the x-axis. Now on the y-axis, I go up to an 80 maximum, and it looks like I've got even numbers, so I can do 20, 40, 60, 80%. That's the highest number that we'll have, but I'm going to keep labeling on to 120. Okay, fill in our graph here. 180, 340, 50, 620, and then 860. Using our straight edge, we're going to draw in our graph, and we can already see this is taking on a V shape. That is V for absolute value. That's our parent function, and it'll look something like this. They're asking us what type of function, and then interpret the meaning of the x-intercept. The x-intercept is where the graph touches the x-axis. That happens at this coordinate point right here. This coordinate point is 5, 0. My x variable is 5, and it stands for hours. So what I'm going to write is at 5 hours, and then my y variable is at 0, and it stands for battery life remaining. So at 5 hours, there is 0% battery remaining. And that's how you explain your x-intercepts. Thanks for watching, guys, and we'll see you next time.